Hello everyone. Okay, so today we are going to be talking about 2024 FRQ number 1. Okay, this was a graphing calculator question and it did show up on the AB and the BC portion. This question focuses a lot on table analysis. All right, so let's get crack-a-lackin' and let's start this problem. All right, people, let's get this party started. Okay, so when we first look at it, we notice, hey, we have a table, okay? Our input variable is t, and it stands for minutes, okay? And we have 0, 3, 7, and 2, and we are given C of t, which is degrees Celsius. So immediately I know that this is not a rate. Not a rate. Okay, that's the first thing we should be looking for. Where are our derivatives? What are we starting with? Okay, so let's read it. The temperature of coffee in a cup at time t, minutes, is modeled by a decreasing differentiable function c, where c of t is measured in degrees Celsius. 0 is less than or equal to t, which is less than or equal to 12. Selected values of c of t are given in the table shown. All right, let's move on to A. Let's answer A first. Okay, so A says approximate C prime of 5 using average rate of change of C over the interval from 3, which is less than or equal to T, which is less than or equal to 7. Show the work that leads to the answer and include units of measure. All right, so right there, let's approximate C prime. Okay, so let's do, hey, C prime of 5 is approximately, okay, using average rate of change that tells us exactly what it is, and over the interval from 3 to 7. So I'm going to have 3 minus 7, and I'm going to use C of 3 minus C of 7. Make sure I make those parentheses look nice. All right, so let's figure out what is C of 3, what is C of 7. C of 3 is 85, so we got 85 here, minus 69, all over negative 4. 85 minus 69, that is, I believe that is 16, so that will be 16 over negative 4, which is equivalent to negative 4. Now, this is approximately negative 4, and let's put our units here. All right, so we are doing average rate of change. Okay, we're approximating the derivative. Whenever we take the derivative or we're doing average rate of change, we have to add a rate. Our first original function is degrees Celsius, so we are going to be in degrees Celsius. Okay, and we're adding a rate to that, so it's be degrees Celsius per input variable, which is minutes. And that is part A completed. We found C prime, and we also included our units. All right, let's go to part B. So, part B, use left Riemann sum with 3 subintervals indicated by the data on the table to approximate the value integral 0 to 12 of C of t dt. Interpret the meaning of 1 over 12 integral from 0 to 2 C of d dt in context of your problem. All right, so this has got 2 main problems that we have to talk about. We have to first use left Riemann sums, okay? And it says the subintervals are indicated by the table. They are, okay? So we're gonna first start with 0 to 3, and we're gonna do the left Riemann sum there. Then we are going to do 3 to 7 and do that interval. And then our last interval that we're going to do with left Riemann sums between is 7 and 12. Okay, so let's do that first bit. So we're going to do 0 to 12 C of t dt is approximately, all right, left Riemann sums. So we have to take the left point y value in this case. So that would be C of C of 0 and multiply the difference between our input variables. Here our range, our interval is 0 to 3, so the difference between that is 3. So again, that is taking our height, which is at C of 0, and times our width on our graph for that rectangle. And we are going to be adding that height at our left point, okay, so that would be C of our left point in this orange interval, which is 3, times the width between our interval, which would be 7 minus 3, which is 4, and we're going to be adding then our height at our left interval for the last interval, which is 7. So that'll be C of 7 times the change in our x's or change in our interval, which is 5. All right. Now let's plug in C of 0 is 100. So then 100 times 3 plus C of 3 is 85. So then that is 85 times 4 plus C of 7, which is 69. So that'll be 69 times 5. All right, then we just got to simplify this. 100 times 3 is 300 plus 85 times 4 is 340 plus 69 times 5. That is going to be 345. Let's add those all together, and we should get the value of 985. Again, you have a calculator, use it if you need to, okay? Now, that's only the first bit. Now we need to interpret the meaning, aka use our words, the meaning of 1/2 over 12 of the integral of 0 to 12 C of d dt. All right, so 1 over 12, 0 to 12 C of t dt. Okay, so immediately I noticed, hey, my bounds, if I would subtract my bounds, 12 minus 0, I get 12. Okay, right there, immediately, you guys need to notice, hey, that is the same as 1 over b minus a, integral a to b of some function, the integral of some function. This is the average value formula. It's the average value of what's the function that we're taking the integral of. So here, we are doing average value of C of t. C of t is degrees Celsius, so it is going to be the average value of degrees. All right, so let's do this thing. So 1 over 12, 0 to 12, C of t dt is the average temperature of coffee. That's what C of t stands for. In a cup from 0 to 12. Always include your range, your time value. All right, that is part B. Okay, let's go on to C. All right, so this is where we're going to have to start getting some things in the calculator. Notice my rule of thumb for my kids. If you see something with decimals as exponents or a lot of decimals in the number, in the function, put it into the dang calculator. Okay, so immediately, the first thing I'm going to do is I am going to put that function right into my DESMOS calculator. Okay, they tell us, hey, C prime. I'm just going to use a function R just so it's a little bit quicker for me. R of x. And I'm using the variable x because DESMOS sometimes has a hard time differentiating variables of t. So I like just to use R, just plain and simple, whenever I have to do any type of integrating or differentiating, if I could help it. Okay, so that is equal to the fraction of negative 24.55 e to the power of 0.101 x. All over x, or all over t. All right, so let's read what the actual problem is. So for 12 is less than or equal to t, which is less than or equal to 20. The rate of change of temperature of coffee is modeled by C prime of t, which is equal to that crazy function that we just put in. So right there, that's the derivative. That's how quickly our function's changing. That's how quickly the temperature is changing past 12, okay? Where C prime is measured in degrees per minute. Find the temperature of coffee at time t equals 20. So they want us to figure out, hey, temperature of coffee, that's the original function. That is C of 20. Oh, okay. Don't we have that? Oh, we don't have that in our table. It stops at 12. So how are we going to figure out what C of 20 is? Right there. we are given the rate. We can figure out the accumulation from 12 to 20 and say, hey, if my temperature is starting at this temperature at 12, how far did it accumulate from 12? That will be 20. Okay, so a couple of things we need to figure out. Let's just figure out what is the integral real fast. But before that, what I'm going to do is I'm going to say, hey, 12 to 20 of the c prime of t dt. Think about this logically, right? Using FTC idea. That is just equivalent to our antiderivative, which is c, when I plug our upper bound in, minus c of 12. So people, our goal is to get what is c of 20. What I'm going to do is I'm going to add that c of 12 over. So I'm going to do integral 12 to 20 of c prime of t dt. And I'm adding, in this case, our initial value, which is c of 12, my bad. And that's going to equal c of 20. So whole idea, figure out the accumulation, then add our initial value, and that's going to give us our value that we want for c of 20. Okay, so let's go over to the DESMOS calculator. Let's figure out the accumulation, because guess what? We're not going to do that by hand. So I'm going to type in integral int from 12 to 20, call my function, which I called to be r of x in this case. Okay, we got that change to be negative 4.60. So technically what that's saying is our coffee temperature changed, it decreased, it went down by negative 14.67. Okay, so that that integral from 12 to 20, c prime of t dt, would be negative 14.670. And I have to add whatever our c of 12 is. Our c of 12 is 55. And that should get us c of 20. All right, so let's physically in our calculator add 55 to that. And that we should get that c of 20 should be equal to 40.329. All right, and that is part C. Let's go and let's do part D here. Okay, for the model defined in part C, let me make this a little bit bigger for us. It can be shown that C double prime, so the derivative of what we were just given, is this function. For 12 is less than t, which is less than 20. Determine whether the temperature of coffee is changing at a decreasing rate or an increasing rate. Okay, so immediately you need to think about what does c double prime of t tell us? That is the rate of the rate. So our coffee is changing at some rate, at an increasing or decreasing rate. We just got to think, hey, what is that value? And if it's positive, our coffee is going to be changing our temperature is changing at an increasing rate because it's already changing and it's going at a positive rate. It's going one more step up. And if our c double prime of t is negative, it's going to be changing at a decreasing rate. So let's graph what c double prime is and let's look from 12 to 20 what is happening. So instead of putting all that in, I'm going to say, I'm trusting my calculator and I'm going to say r prime of x. We got to put parentheses around the x. Okay, and that's the only function I'm going to show. I'm looking for from 12 to 20. So if 12 is, let's put x is equal to, let's get fancy here. Let's put brackets. 12 is less than x, which is less than 20. So I'm restricting that domain here for DESMOS. And notice here, that whole time, our second derivative is going to be positive. Okay? So what I'm going to say on our explanation is based on our graph, of C double prime of t. C double prime of, not G, my bad, C double prime of t is greater than 0 for the interval (12), which is less than x, which is less than 20. Thus, the rate of change is a rate of change of the temp is increasing. Thus, I always try to reframe it and put it in their calculus, the terms that they want. So just from the question. So thus, the temperature of the coffee is changing. So the rate is changing at an increasing rate. And that's because our second derivative, that whole interval, is a positive y value. All right, and so that is those 4 problems. Let me zoom out there so you can get that final answer. Those are our 4 problems for this FRQ for 2024. Let's now talk about how the AP graders graded this FRQ. Okay, so the first point was given if you had the correct estimate and work shown for that estimate for the part A. So if you had all of this analysis here for part A, okay, you could have stopped right here, that 85 minus 69 over -4. They would give you a point there, okay? But you needed that whole setup. You also got a point for the correct units. So if you had the correct units, degrees Celsius per minute, they would have gave you that another point as well. Okay, so that is for part A. Part B, let's go and look at this. So they gave you a whole point if you correctly did the Riemann sum. So if you had the correct Riemann sum setup, let me change color to red. If you did the correct Riemann sum setup, they would have given you another point. So if you did left Riemann sums correctly, then they would have gave you a second point if you correctly found the left Riemann sums number. Now, you could have stopped right at this 100 times 3 plus 85 times 4 plus 69 times 5. You could have stopped there. And lastly, for this problem, they gave you 1 point for your correct explanation of the integral, the 1 over 12 times the integral of 0 to 12 of c of t dt. That's another point. So that was worth 3 points for that problem. All right. Now, this part C, this is also worth 3 points. They gave you 1 point if you did the integral from 12 to 20 of c prime of t dt. They gave you 1 point here. They also gave you a point if you use the initial value at 12. And then you got a final point for the answer of 40.329. And lastly, sadly, all this beautiful explanation would only have gotten you 1 point. That was all of the grading for this AP FRQ for 2024. That was all of this FRQ, this 2024 question number 1 FRQ that you could use a graphic calculator for. It did test a lot of table analysis information. You had to do average rate of change, Riemann sums. You had to understand what to do with initial values and all that type of stuff. So if you would like some more calc help, please look at my other videos. I am going to be going through all of the FRQs since around 2000 that I can find on the internet. So please check out the other videos and ask any questions that you have in the comments. Thank you for watching. Watch another video. Good luck studying.